Now we're going to talk about vertical tangent lines. Let's read this example together. What are the points on the graph of y cubed minus 3x squared plus 2 equals y squared where the tangent line is vertical? Keyword here, vertical. So it's not like horizontal, right? We know a vertical tangent line goes like this. Oh, that was terrible. I'm just not good at drawing. I'm not good at writing. That's why I went with this particular screen. It writes much better than the other ones I've used. But anyway, this is what a vertical tangent line looks like, and it's not going to be, it's going to be different than horizontal. So keep that in mind. You can kind of be thinking about what this means in terms of the derivative. So if you said that the dy dx is going to be undefined, since it's a vertical tangent line, you are correct. So basically what we're going to do is take the derivative implicitly and figure out where this is undefined. Pretty simple, right? So let's go ahead and implicitly differentiate this function. We will have to multiply these by dy dx when we take the derivative. And here we go, 3y squared dy dx minus 6x plus 2, minus 6x equals, derivative of this is 0, so it goes away, equals 2y dy dx. That's going to lead us to our next step, which is to find dy dx. Now we do have to get dy dx by itself when it's vertical tangent, and that's because we want to figure out where it is undefined, and it has to be by itself. So again, you have to find dy dx for step 3 when you're solving for a vertical tangent. So that means you're going to pull out a dy dx. We're used to doing that already. Gone over that. And then we're going to divide both sides by whatever's left over. And we get dy dx equals 6x over 3y squared minus 2y. So how can we figure out where dy dx is undefined? Well, it's always going to be defined on the top of this fraction, right? Only when the bottom equals 0 will dy dx be undefined. So we're going to set, in this case, the bottom equal to 0. All right, now it's not always, the case like that. Like let's say you get a square root in your implicit derivative, then that square root can't be negative, so you would see where that occurs, and that's where it's undefined. So it just depends on your derivative function. So set the bottom of that fraction equal to 0, pull out a y, and then set each of these equal to 0. You can see when y equals 0, it's going to be undefined, and then it looks like y equals 2/3. So it's going to be undefined at y equals 0. Add 2 to both sides here, divide by 3, and y equals 2/3. It will be undefined at those two values. However, we need to plug these y values back into the original equation to determine their corresponding x values. So our original equation was y cubed minus 3x squared plus 3 equals y squared. We're just going to plug in our first value, we get back 0. And we end up with, so if we add 3x squared to both sides and divide by 3 and take the square root, we get the square root of 2/3 plus or minus. So when y equals 0, x equals plus or minus that. Now since we plugged in a y value of 0, that's our y value, these are our x values. It's kind of weird, you're plugging in a y to figure out an x. It happens, especially with implicit functions. Or not functions, implicit equations, formulas. Now for the other point, we figured out when y is 2/3, the equation is undefined. The derivative is undefined, so we're going to plug in 2/3 into the original. And we get 2/3 cubed, 8 over 27, 2/3 squared, 4/9. Now we just have to get x by itself. So what we're going to do here is add 3x squared to both sides to get it on the right. And we are going to also move the 4/9 over. I hate doing 2 steps at once, but in this case, it's the way I typed it. Basically, move this over with the other things that aren't x and move this thing over to the right. All right, so we end up with this, and then we can just combine off these three numbers by having a common denominator of 27. Pretty fun stuff here. We get 50 over 27 equals 3x squared. Then we can divide by 3 or multiply by 1/3. We get 50 over 81 equals x squared. Take the square root. Don't forget plus or minus. and we get plus or minus square root of 50 over 9 equals x. The square root of 50 can be broken down into 5 radical 2. So final answer for our x value, plus or minus 5 radical 2 over 9. That means when y is 2/3, these are our x values, and we have 2 more points where we have a vertical tangent line. Now that we've done that, these are all 4 points where we have vertical tangent line, and just to refresh your memory, we found out by taking the derivative and figuring out where dy dx was undefined, namely in this case with the denominator equals 0. Here are the decimal approximations to each of these points. That way we can kind of figure out where they go on the graph. Now that we've done all that, let's just take a look and confirm our results. We can see these are the 4 points we found that have vertical tangents. In other words, it goes straight up and down. These 2 green points and these 2 purple points. Here's what the 2 purple tangents look like up there, straight up and down. And here's what our 2 green tangents look like. Pretty interesting. This problem was pretty thorough and involved. It's kind of like taking everything we learned on Implicit and putting it into one problem. And here's all 4 tangents graphed together. That's it right now for implicit tangent lines. We did vertical, horizontal, and just finding the equation for one. If you have any other questions about this, let me know.